Hello and welcome to another Archimatix video tutorial. Today we're going to be taking a look at some basic nodes in Archimatix and how they can be used to make something like GrayShip, the spaceship that you just saw flying in formation over a desert-like alien world. Looking at the exploded diagram of the ship, we can see that various nodes are best used to make various parts. We use the extrude node to make the deck of the ship and the long spine-like elements that run the length of the ship. Plan repeater is used to distribute cylinders around the basic plan shape of the hull, and radial repeater is used to distribute structural elements around the saucer part of the ship. The saucer itself is made with a lathe, and pair repeater is used to distribute the propulsion units, which are really cylinders, in the rear of the ship. After you've created the GrayShip parametric model, you can modify its parameters to create many variations, assembling a veritable galactic armada in minutes. So now let's see how the GrayShip parametric model is created right in Unity using Archimatix. As with so many human endeavors, we need a plan. And here, we quite literally need to start with a plan shape. For GrayShip, let's choose the cathedral plan shape in the 2D library in the left-hand sidebar. We will use this shape to generate much of the 3D meshes that form GrayShip. We can see in the scene view that our scaling figure, billboard robot Kyle, is giving us a sense that maybe this shape needs to be a little bit bigger to reflect the size of the spaceship. I'll grab the various handles of the shape and alter the form. Rather than scaling it, I'm actually changing parameters. These parameters are also reflected in the node palette in the node graph editor. We can use the output of this node shape to connect it to an extrude mesher in the right sidebar menu. And already we have what appears to be a basic hull or deck of the spaceship. This lower green handle of the extrude controls the radius of the bevel, and the cyan handle up above controls the number of segments in the bevel to smooth it out. We can, of course, continue to alter the plan shape as much as we want. Since Archimatix is a non-destructive editor, all the changes that we make continue to ripple through all of the nodes in the node graph. With the top green handle on the side of the extrude, I'm able to change the taper. Back in the node graph editor, let's add a cylinder to the scene by clicking on the 3D library in the left-hand sidebar. This cylinder can be distributed around the plan shape using a plan repeater and give us a kind of pontoon structure around the edge. Let's take the output of the cylinder and connect it to the plan repeater as a node mesh. For the input shape for the plan repeater, we can reuse the same shape that we used for the hull. This distributes the cylinders around that shape. We can select any one of these cylinders to modify it. So here we've selected at random one along the side. We can use the normal Unity transform tools, so we can rotate and translate the cylinder to position it about where we want, and we can see that it affects all of the other cylinders. Since the same plan is being used to generate the deck as well as the cylinders, we can alter that plan shape and be altering both at once. So as we make this longer and shorter, we see the number of cylinders on a length of the plan is changing. If we rearrange the node graph, we can get a sense of what's going on here. Namely, that we've got a single plan shape that's being fed into two different form generators, the extrude and the shape repeater. It's worth noting that we can alter the view of the thumbnail by using the little icon, orbit and dolly icon, in the upper right-hand corner of the thumbnail. To add material to these forms, we can create a material tool node from the sidebar, or more conveniently, click on this button, which generates a node and connects it. We can edit the material using the sliders in the material node for scaling and for shifting. If we click on the cylinder and hit the F key, it frames the cylinder both in the scene view and in the node graph. We can create a material for that. Let's choose the Sci-Fi 003 material, complements of algorithmics. While the overall hull has this concrete texture, let's differentiate the center of the deck with another material. The extrude has another parameter input, which is called top cap material. If we create a new material for that using that button, we can choose the Sci-Fi texture again, Alternatively, we could have linked the sci-fi texture from the cylinders into this top cap material, but sometimes it's good to keep the materials separate if you want to vary them separately. It would be nice to have a little bit more of a transition from the sides of the decking to the new material on the top cap. So the extrude also has a parameter called lip top and lip bottom that we can adjust. This lip is really an offset that creates new geometry to make the cap smaller. Lip edge is another parameter that lets us sink the cap down a little bit and provide a new edge to it. So we have the basic form of the GrayShip pretty much done here. In the heat of adding nodes and connecting them, the graph can get a little messy. We can use buttons on the side of the input parameters to hide nodes, or a button down at the bottom of the node graph header, which will hide all tools at once, and another button which will fold up all the parameter control foldouts. Now that we've tidied up a little bit, let's take another look at the plan repeater. There's a parameter in plan repeater called inset. This parameter restricts the length of the segment used for the repetition. So with that, we can free the corners up. As it turns out, plan repeater gives us the opportunity to place things at all of the sharp corners of the plan as well. So if we look at the inputs, we see that so far we've used the node mesh input. Nodes are along a segment, and we also have cell meshes that go in between those nodes. And we also have the corner mesh. So let's go ahead and we're going to copy and paste this cylinder node and feed it into the plan repeater as a corner mesh. We can see that it's tilted at the corners, bisecting the corners. I think in this case we will make it more sort of straight corner bumpers, and we'll increase the radius of those cylinders and rotate the cylinders so that they are vertical, and adjust the height and radius. So this was a copy of the cylinder, but it's no longer related to the original cylinders in any way. So it's free to sort of operate on its own. Let's use this bottom green slider handle on the cylinder to increase the bevel and make it very large. While it's not clear what the aerodynamic function of these corner pieces are, they do help to articulate the corners. Looking at the graph again, we can see that we've got a single plan feeding into all of this form generation node work. So if we multi-select these nodes and group them by clicking on the grouper, all those nodes have been encapsulated in the grouper. By double-clicking on the thumbnail of the grouper, we can look inside and see the subgraph. We also see that a plan parameter has been added to the grouper interface, essentially redistributing the plan from outside to the internal nodes that want to use that plan. This means that we can change the plan very easily, and the new shape will ripple down through everything that's going on inside of the group. So what we'll do is we'll delete the connection for the plan, we'll connect it with a new plan, and so there we see all of our logic is the same. So let's reconnect the original plan. And next we'll think about the round part in the front, the saucer. If you recall, the saucer is located in the front of the spaceship. And so since all of these objects are concentric, it would be great to be able to create them in a new coordinate system that's located in the front of the ship. Our current center is in the back of the ship. But if we create a group and move the group to the front, then that will be our new theater of operation. So I'll just click on the group icon. We've created a new group node right inside of our old group, and I'm just renaming it Bridge. And with that group node selected, we can translate it to the front. This will essentially be our center now. So if we go inside of the group and create a cylinder by clicking on the left sidebar menu, we see that the cylinder has indeed ended up there. By selecting the group again, I can reposition it, maybe to be a little bit further up. I'll select the cylinder again and frame it, and we can begin to adjust it and set its material. We could do this either as a default material for the entire model, a material node that we add to that cylinder or a material node that we add to the entire group. For now, we'll add it to, we haven't really specified a default material for the model, so let's make it concrete. Now, any new object created will have this concrete attributed to it. Next, we'll make the dome of the saucer. I'll choose a dome molding profile from the left sidebar shape, and we will connect this to a lathe mesher. So that makes a dome immediately, and we can manipulate the shape itself. And since we want a hole in the center, let's use the lathe radius tool, which is that yellow handle in the middle. This expands the radius of the dome without changing the shape profile itself, leaving a flat part in the middle, which will turn into a hole in just a minute. I'll just move the lathe down to the deck a little bit. And if we go back into the node graph editor and select the lathe, we see a parameter called top cap. If we uncheck that, then we have made the hole in the middle just by taking that top cap away. Now we'll make the glass bubble dome to fill the hole by using the same dome profile connected to another lathe. We'll add a material to the dome by clicking on the Material Node button, which creates the material node, and choose AX Glass. We'll move the dome up so that it's sitting on top of the first one. And we don't want to use this lathe radius because we don't want a hole in the center. So instead, we'll just adjust using the curves handles. Now we're ready to make the ribbed structure around the dome or the saucer. For that, we create a single rib, and then we're going to repeat it. I'm going to use a shape called shallow curve shape and connect it to an extrude mesher. That'll end up right in the center under the domes. We can hit the F key to frame and make the extrude a little bit smaller. It would be nice if this piece was always centered. So I will go into Transform and choose Align Z as centered. And now as we adjust the extrusion, it is always centered. I'll use that bottom green handle that we've seen before with extrude to add a bevel and adjust the shape a little bit more using its handles. And let's use that cyan handle to change it into a hard chiseled bevel. The next thing to do is to see how this is going to look as it's repeated around the dome. So I'll choose a radial repeater, and right away we see that we have a couple of new handles for radial repeater there. But first, let's orient these things to be sort of pointing towards the dome. I'm going to change the axis orientation until I see that, in this case, the Z-axis orientation looks pretty good. And I'll select the radial repeater, adjust its thumbnail a little bit, and we'll use the radius repeater handles to adjust the radius and move those parts about where they could be on the dome. We've got these clicker handles here that let us add more and fewer objects into the repeater. And I can select any one of these fins to operate on it. And of course, as we've seen before, it'll change all of them that are being organized by the radial repeater. We can continue to grab different objects and handles and manipulate the parametric objects that are within the group that we're working in. And then we can look at this breadcrumb trail here and click all the way back to the model. Click down into the first group. Let's take a moment to rename this hull and also to tidy up the rest of the group. We haven't been up at this level in a little while because we've been working down in the bridge or saucer group. Now that we see the saucer group as just a node in this hull group, we can think about how it looks here. So I'm dialing and orbiting the thumbnail a little bit. And with this group selected, we see that it operates as an object in the scene as well with its own bounding box. Of course, the plan is still manipulable. I think we're ready to move on to the long part of the ship here. We need to have a spine shape. I think we'll use the same shallow curve that we used before, but we'll make it quite a bit longer. And we'll feed that into an extrude mesher. We'll multi-select these two nodes and move them a little bit to the right so that we can see them better. And adjust the axis so that this is going in the, let's see, that looks good, the x-axis. Now we can manipulate the handles in the curve itself to make it longer. And we'll just keep on adjusting, moving things around, making them wider, not unlike what we were doing with the fins or ribs around the saucer. We'll add another cube to the model, and we'll just stretch it out and make it some other piece that's trailing back behind the ship a little bit. And let's give it that sci-fi material. It's nice to have a two-tone effect going on between the concrete and the sci-fi. Alternatively, we can open up the material node from the hull and delete that node and just connect this to reuse that material. To add a ring shape under the back of the ship, let's use a rounded rectangle and feed that into a lathe mesher. We'll use the radius handle of the lathe to pull it out, and then we'll use the shape handles to manipulate the cross-section. Here I'm rotating the section shape, and once again we can continue to manipulate the shape through its section, through its lathe tool, and even just through the Unity transforms. We'll add another material, and something a little bit different from what we've had before. Scaling the material and shifting it. Once again, it's time to look at the graph and see what a mess we've made with all of this modeling. It's really nice having the saucer or the bridge group there. Maybe these objects that we've created in the tail section of the ship could be in a group. Let's multi-select them and hit the grouper icon. And there we have it. We can adjust the thumbnail so it really does feel like a component, like we did with the grouper for the bridge or saucer section. We can double click the thumbnail to go inside and see that all is in order in here. Let's go back into the tail section to add a propulsion unit. First we'll tidy up by closing all the control parameters. And let's start by adding a cylinder. So we'll just click on cylinder in the sidebar, and this will be our first propulsion unit. We'll size it a little bit. We'll turn its axis down so that it's running along the length of the ship. Continue to modify its radius. Now to make 4 of these, the plan is to use a pair repeater. So we're going to take the output of the cylinder and feed it into a pair repeater. And the pair repeater has very simple handles for separation. If we add that pair repeater to another pair repeater, we've got a pair of pairs. This is a very useful mode of organizing objects into pairs. Once you start looking at machines and buildings, you start seeing pairs all over the place. So we can continue to modify the pairings, the separations, modify the dimensions of the propulsion units. Again, it's great being able to work with a non-destructive system to have these cylinders in their pair groups before doing the final manipulation of their forms, rather than manipulating one form and trying to think of how it's going to look once it's distributed through space. For these, we'll add a very large radius of bevel. So even though it looks like a capsule, it's really just an extruded circle with an enormous bevel. At this point, the GrayShip is pretty much complete. We've got all our parts in place. We've got our non-destructive system of handles that you can keep on manipulating any of the subparts. This is really the power of parametric modeling. One more thing we should do before we end is take a look at the plan again. So I'm going to go back up to the model level and click on the original plan. And in the output, if we open the foldout, we see other things that we can do with the plan. For example, we can thicken it. So you can see that we've got a kind of double shell going on here with the plan. And until you actually thicken it, you're not even sure what it's going to do to the model. So there's a lot of serendipitous form generation that starts happening as you've continued to build the graph into a more and more sophisticated array. So here we have it's the exact same model. It just looks very different just with the movement of a couple of handles. So I hope you've enjoyed this tutorial, and I hope you have fun with the GrayShip. It's all yours, included in Archimatix. You can read more about GrayShip in Chapter 7 of the Quick Start Guide in the Documents folder. Thanks for joining us, and see you next time.